If you happen to hold with the idea that the moon is made of green cheese, you'd better hide, unless you're ready for a rude awakening on this morning's Journey into Nature.
Journey into Nature, a special series of programs produced by WNBC in cooperation with the American Museum of Natural History, an institution dedicated to the search for knowledge in the fields of natural science. Within the many exhibit halls of the museum, you will find accurate representations of what man has learned of himself and the world that surrounds him. Journey into Nature visits many of the exhibits, talks with the staff members and research scientists in order to capture in sound the wealth of knowledge on display, to bring you the excitement of learning, to explore the wonders of the world. Here now is your host, Tex Antoine.
Thank you. I've just had the opportunity of looking over a special pre-publication copy of the American Museum's new magazine for young people, Nature and Science, that's going to start coming out next fall. And I'm not quite sure what's meant by young people, because I found most of the articles very fascinating myself, especially the lead story about the secrets of the moon by Dr. Franklin M. Branley, associate astronomer at the American Museum Hayden Planetarium. Dr. Branley, who's also a consulting editor for the new magazine, joined us several months ago to talk about Project Apollo and our various rocket probes aimed at studying and eventually reaching the moon. But after I read Dr. Branley's article, I thought it would be a good idea to talk with him once again about the secrets of the moon, what we now know and what we're speculating on. So, good morning, Dr. Branley.
Good morning, Tex. Very nice to be here with you.
Thank you. Dr. Branley, do we know whether the moon is made up of rocks similar to those composing the Earth?
Well, not directly, Tex. Actually, most of the information that we have about the moon we get indirectly. For example, we can determine the density of the moon. If we took the Earth, for example, all together, mixed air and rock and soil, and weighed it, we would find that it would weigh about 5.5 pounds to the pint. So we say that the Earth has a density of 5.5. If we did the same thing with the moon, we would find that it weighs 3.3 pounds to the pint. So the density of the moon is 3.3. Now we know also that the granite-like rocks on the Earth have a density of 3.3. So you and I can put both of these things together, and we can surmise that the structure of the moon is rock-like granite with a density of about 3.3. But this is not something one should conclude is true, because maybe there are great variations, and maybe it's not a homogeneous thing. There might be parts of the moon where the density is very high, other parts where it's very low, and we may be completely misled by this kind of evidence.
So this again is a speculation based on the limited facts that you do have, and it'll take a man on the moon to find out for sure, won't it?
Well, it really does. It takes a man on the moon, or it takes the kind of apparatus that we hope to be able to land on the moon and make first-hand investigations remotely.
Well, Doctor, what about the surface of the moon, the dead white look it presents to us on Earth? Do they believe actually that the moon is covered with a form of dust?
Well, this has been mentioned many times, and we do know that space itself contains a great deal of dust, and that the Earth intercepts this dust, and it accumulates on the Earth. Now, the moon similarly would intercept the dust, and we suspect that for millions of years, cosmic dust has been raining down on the moon and accumulating. The feeling among some people is that the moon is covered by loose dust that reaches a depth of about 1 mile in some places. And then other people believe that the moon is covered by dust that has packed tightly together. Since there is no air on the moon, the particles of dust would not be held apart by air, you see. And so the particles would go in and fill up the spaces. So you have a crust-like formation. So whether it's dust, loose dust, or this crusty formation is not entirely clear, although there is some evidence of a dust-like explosion when probes have landed on the moon. But even that is the kind of thing you're really going way out on a limb if you reach any conclusions about it.
Well, that would present a very definite problem for a landing. If you have a puddle of dust a mile deep, the thing would disappear right into the dust, wouldn't it?
Yeah, that's rather a serious problem, I'd say.
Well, in talking about the surface of the moon, Doctor, we can't leave out the well-known craters that give some semblance of the face of the man on the moon. Is it still concluded that the great craters on the moon were made by meteorite landings?
Well, as you know, Tex, there have been these two basic explanations that the craters were formed by meteorite collisions and that the craters were formed by volcanic activity. And I think that perhaps most astronomers are doing a very nice sidestepping operation here, because the fellows who are, I think, are most on the ball are those who are saying that the craters were formed in both ways. This way they avoid a lot of arguments. We don't know, we can't say for sure whether they were formed exclusively one way or another. You talk to the people who believe in the volcanic theory, and they can give very strong arguments based upon observation that the craters developed out of volcanism. And then if you talk to those who believe in the meteorite collision theory, they can give strong arguments supporting their point of view. They, for example, in the case of volcanism, they can show that a crater here on the Earth decomposes in such a way as to form the inner walls similar to those inner walls we see on the moon. And in the case of meteorites, people point out that many of the craters are not round, but rather they are oblong or ovoid sort of in shape, indicating that a meteorite might have come in at an angle and gouged out the surface of the moon. You know, with a high wall on one side and a sloping wall on the other side. Or there are places on the moon that look as though they have been scratched by a meteorite of considerable size that has just come in and dug its own channel.
Oh, kind of a ricocheting shot off the moon.
Yes.
Well, I guess there would be a point of logic since it lives in more or less the same area as the Earth, and we have craters on the surface of the Earth made both ways by impact and volcanic action. You could attribute that to the moon, too.
Well, this is true, and this is the kind of argument that is followed. The thing that causes puzzlement, not that there's only one, but one of the factors that causes puzzlement is that the craters are so tremendously wide. You see, some of these craters are about 150, 60 miles across. And if you have a volcano that makes a crater of that kind of dimension,
that they contain
a good many fissures and are pockmarked with small craters. And we are sure that as our equipment improves, we're going to see even greater signs of roughness and unevenness. You see, right now, even with our best equipment, a feature has to have a dimension of 1/4 of a mile, approximately 1/4 of a mile, in order to be identified. We can't see anything on the moon that is smaller than that. So that's a pretty large formation. When you think about the Earth, and the different formations that are much less than a quarter of a mile in dimension.
Oh, yes, I can see that the smaller definitions of the surface have never actually been seen by man.
That's right.
Well, Doctor, for the amateur astronomer, when is the best time to see the surface features of the moon?
I'd say at night. Really, the best time to see the full moon for a person who's going to be content with gross features would be when the moon is full. And there is a full moon tonight, and if it's clear, you might just go out and take a look at it. But if you want to see details on the surface, you have to have a time when shadows of the lunar mountains are falling across the plains or the seas. And the only time you don't get them is during full moon. So in other words, if you want to see details of the lunar surface, then you should look at the moon any other time than full, during a gibbous moon or a crescent or a quarter moon. And you can do this in the early evening or late at night, depending on your schedule and depending upon the particular phase of the moon at the time.
Well, does the amateur moon watcher need any kind of special equipment to see the features of the moon?
Well, you can really get quite satisfactory results, Tex, by using a good pair of field glasses. The trouble with field glasses, however, is, aside from power, is that they wiggle. You just can't hold them still enough, you see, and so the whole image of the moon jiggles about in the field. One way of doing this is by mounting the glasses in a tripod and keeping your hands off them. If you can afford a telescope, you should get one of relatively low power, 30, 40, 50 power, for looking at the moon. This is all you need, and it's a great satisfaction to look up there and be able to identify craters for yourself and actually see the shadows move as time goes by. You can do this with a very inexpensive telescope.
Well, that's a fascinating approach to the moon for the average person, quite available to them. And Dr. Brandley, I'd like to ask you a few more perhaps technical questions about the moon and some of its secrets. But right now, let's pause for a brief message from the American Museum of Natural History.
Dr. Brandley's article about the moon, which is the subject of this morning's discussion, is typical of the many interesting and timely features that will appear regularly in the magazine Nature and Science. Starting in September, this important new magazine for young people will appear every 2 weeks throughout the school year and twice during the summer. Charter subscriptions at a special pre-publication rate are now being accepted at the museum. If you teach in the middle elementary grades, you'll want to use this new periodical with its special teacher's supplement. Or if you know a science-minded youngster between the ages of 9 and 14, why not give him or her the thrill of being a charter subscriber? To learn more about Nature and Science magazine, address a postcard to Department J, the American Museum of Natural History, New York 24, New York.
Thank you. This morning, we're getting all of the latest scientific lowdown on the moon from Dr. Franklin M. Brandley, Associate Astronomer at the American Museum Hayden Planetarium. Dr. Brandley, as you know, one of my major interests is weather. And I've often wondered what we might expect in terms of wind, rain, and the like on the moon.
Well, Tex, I'm afraid I'll just have to be very realistic here and say that you'd be out of a job on the moon because there isn't any weather. It's always the same. There's no wind, there's no rain or sleet or snow. One day is exactly like another. Of course, the days are rather long, 14 of our Earth days, and the nights similarly, but every day you're going to get up in the morning and you're going to see exactly the same sky out there, no difference.
That's true. With no atmosphere, there would be no variations then. The only variation is, in fact, associated with our weather would be temperature change, wouldn't it?
Well, that would really be extreme. Here, if we have a temperature change of 60 or 70 degrees in 24 hours, that's something to
yes.
make headlines about. But if you were on the moon and looking directly overhead at the sun, then the temperature at that location would be about 215 degrees above zero Fahrenheit. And at the same time, however, on the day side, as you moved away from that location toward the edge of the moon, the temperature would drop off very rapidly. And at the edge of the moon, in daytime, it's about 58 degrees below zero. But then, as time goes by and you are carried from this subsolar point into the night half of the moon, then the temperature at your location and over the whole night half would be about 250 degrees below zero. So you have a range of something like 450 degrees in the day-night cycle.
Wow. That is weather in itself as we associate it with our own particular comfort. Well, this great variance in temperature then would indicate that there is absolutely no life on the moon, I would assume.
Well, not only from that standpoint, it's been suggested, Tex, that there might be some locations on the moon, deep crevasses and such, into which the sun doesn't shine, and so the temperatures there would not go very high, and they would not be too cold, because when we talked about temperatures just a moment ago, we were talking about surface temperatures. And not about the temperatures that might exist, say, 6 or 8 inches underneath the crust of the moon. So these people surmise that the temperature conditions under the crust and in crevasses might be within the range in which some kind of life conceivably could have existed, if indeed it doesn't exist today. But certainly it would be no high form of life.
Well, what about that other side of the moon that we do not get a look at? What do we know about the far side?
Well, you recall the Russian lunar probe that photographed the far side and revealed to us simply that there are light and dark regions. Little more than that could be concluded from those photographs. But from the photographs, again, we can extend the features that we know along the limb of the moon around to the other side, and they do agree 100%. So actually, we know very little about the far side of the moon, except that which we obtained from that particular series of photographs.
Well, hasn't there been some speculation about the far side of the moon being an excellent place for radio astronomy?
Well, that's more than speculation, Tex. This is a fact. Because the radio astronomer is plagued continually here on the Earth by all of the man-made radiation that abounds around us in the air envelope. And so whenever you set up a radio telescope, you have to have very delicate equipment to select out of this tremendous maze, or mess, you might say, in some cases, that which you want. It might be a very weak signal. It is a very weak signal. On the other side of the moon, you would be shielded from electromagnetic radiation from the Earth, and you would have a pretty clear view of the entire universe.
Well, Doctor, referring back to the moon's atmosphere, or lack of it, do we believe that the moon has an ionosphere, which would, of course, facilitate radio contact from one point on the moon to another point?
Well, this is a highly debatable question too, Tex, because the data that we have are so limited. But those probes that have carried instruments for measuring ionic frequency have indicated that there is a nebulous ionosphere in the neighborhood of the moon. And this is an extremely interesting phenomenon because it indicates that there is an electromagnetic condition existing in the lunar environment.
That means then that the moon has a magnetic field much as the Earth has?
Well, this is the easy explanation because we do feel that our ionosphere is held to the Earth by the Earth's magnetic field. And there are many reasons for so believing, because when we have fluctuations in magnetic field, we have fluctuations in the ionosphere, and these, of course, we experience by the very unusual manner in which we can pick up radio stations. You know, sometimes at night, for example.
The freak bounce, yes.
Yeah, you pick them up from way out in California somewhere when you're on ordinary AM tuning. But the evidence that we've gathered by instrumentation indicates no magnetic field. But
Isn't that strange?
But it doesn't mean there isn't any. It might mean that our instruments weren't sensitive enough or didn't get in close enough to measure a magnetic field.
And we hope to improve on that in the very near future, I imagine.
Yes, I would suspect that within a few months now we'll get better data than are now available to us.
Well, Dr. Branly, this certainly has been an interesting discussion, and we'll be on the lookout for the museum's new magazine, Nature and Science, in the fall, to see more of your information about the moon, the planets, and the universe. We've just had the pleasure of talking with Dr. Franklin M. Branly, consulting editor for the new magazine and associate astronomer at the American Museum Hayden Planetarium. This is Tex Antoine inviting you to join me here at 660 on your radio dial next Sunday morning, when I'll be waiting once again to escort you on another journey into nature.
Journey into Nature has been a special program produced by WNBC in cooperation with the American Museum of Natural History. Join us again next week as we explore the museum, seeking out the natural wonders of our world. Journey into Nature is produced by Gary Stradling. Your host, Tex Antoine. This is Fred Collins. This program was pre-recorded and heard around the world through the facilities of the Voice of America and the Armed Forces Radio Service.